In the high-stakes world of industrial processing, aging facilities often tell a silent story of service, marked by the gradual progression of corrosion. Engineers face a recurring dilemma. Is the equipment still safe to operate under current conditions, or does it require a costly full-scale replacement? Technical precision is the first step. Advanced non-destructive testing methods are utilized to quantify the actual condition of the steel beneath the surface. Ultrasonic thickness testing allows our inspectors to peer beneath the surface and accurately measure the remaining wall thickness of critical pressure vessels. Every pit mark is meticulously documented. We build a complete profile of the asset's state to understand its structural integrity and performance history. This field data is vital for a reliable assessment. Without precise measurements, any subsequent engineering analysis is fundamentally incomplete and unreliable. Transitioning to the office, raw inspection data is transformed into sophisticated models that simulate real-world operating conditions and mechanical stresses. Finite element analysis allows us to visualize and quantify the complex internal stresses acting upon the weakened structures of aging industrial equipment. By comparing physical states with stress distributions, we identify failure risks through a science-based management approach that ensures maximum plant safety. Our methodology is grounded in the API 579 standard, providing the legal and technical framework for quantifying asset safety and remaining life. Every calculation is a step toward validation. We ensure that every piece of equipment we certify meets the rigorous safety margins required by modern industrial codes. When an assessment indicates a repair is the viable path, precision execution becomes paramount. Quality welding restores the critical pressure boundary. Precision grinding and surface preparation ensure the repair meets the highest standards, preventing localized stress concentrations in the refurbished metal. However, if degradation is too severe, a strategic replacement is planned. This minimizes long-term risk and ensures operational reliability for decades. FFS assessments provide the financial clarity needed to balance immediate repair costs against the long-term capital expenditure of full equipment replacement. Advanced assessments look deeper into complex flaws like cracking. Utilizing fracture mechanics, we can predict whether a crack will remain stable. By calculating stress intensity, we determine if a crack will propagate under actual operational loads, ensuring catastrophic failure is always avoided. Understanding the root cause of failure, whether it's fatigue or corrosion, is the key to preventing recurrence and ensuring long-term asset reliability. Our findings provide the documented proof that equipment is fit for service. Certification gives facility owners the confidence to continue safe operations. The result is a plant that operates with absolute confidence. Reliable assets mean safer workers, reduced downtime, and significantly more efficient production. Visit peakacademy.com today to master the science of technical excellence. PEQ Academy. Engineering the right decision for your facility every time.